All right. So word on the street is the homework was too easy. So I think besides the couple of, well, one of the questions was perceived to be a little complex. We'll talk about that today. And then the issue with reading in a full sentence. If you were on Slack, you saw my fix for that. If you're not on Slack, get on Slack because as soon as I see an update to the assignment, I'll put it up there. But then my understanding is online GDB was hit and miss over the last couple of days. So I figured I just give everybody zeros and that would just work, right? So turn something in. If you weren't able to access online GDB, it's easy for a teacher to say, well, you should have started your homework earlier. Well, I didn't start my homework till the night before when I was a student. So it's just give me a note saying you tried to do it. Online GDB was down. Like I said, homework is practice for the big game. I'm not going to penalize you. Just give me something to grade. Make sure you pay attention to what we're doing today and everything will be okay. Sound good? All right. So,
I have a quick question.
sure.
So when you're dealing with code, is all the code supposed to be inside of the main, or can some of it be like on top of
As far as you know right now, all of it's going to be within Maine, but very, very, very soon, perhaps today, you're going to see us move outside of Maine.
Okay, because when I was doing my homework, like some of the stuff that I saw said like there's a couple of like.
If you were doing this assignment with more programming knowledge, you would certainly create some functions to do stuff. Like for instance, checking to see if something's a lowercase character. You probably would put that inside of a function. Is it an uppercase character? Things like that, but we don't know about functions yet. So we have to solve the problems in terms of what we know. Then I show you a little bit better way of doing it, but 100%. I would say in general, let's go back to my statement I've made about all programs begin and end with main. In general, you want main to be pretty short. Main's kind of like your quarterback. It's going to be saying, oh, pass the ball over to this guy, work on some stuff, come back when you're done. Then pass it over to this guy, do some stuff. So main ends up being kind of your play-by-play, almost high level dictation of what's going on, where your actual logic tends to be in other places. So you're right. In fact, generally main is among the smallest parts of your program. But for us right now, everything's in main. That's where we live at this exact moment. All right. Let's see here. Well, hopefully Blackboard's up. Otherwise, somebody will have to tell me what the questions from the assignment were. Let's do phone calls. I just got the new iPhone, so it's no longer Duo is no longer working on here. I have to spend 3 minutes and fix it, but I didn't. What? What? Oh. All right, so let's look at what the homework was. What class is this? This is homework 4. All right. Step 1, reverse string. And as we hit the sticking point areas, I'll explain some stuff out. So if you saw my message on Slack with the getline function, I'll kind of give you some commentary on why that worked that way. Not that important at the end of the day, but interesting for us to think through. These are things you run into as a programmer. Okay, so task 1, use a for loop to iterate through a string, output the characters of the string. All right, we're supposed to prompt the user for a string. Now, one thing I might do if I were you as I'm going through these assignments, whenever it says prompt the user for something, I might start off when you're writing the homework to hard code it into a variable and then write the logic. And then later on, once your logic's working, go back and change it to a prompt. Otherwise, when you're working on the assignment, every single time you test it, you're having to type crap in over and over and over and over again. You'll find life a little easier doing that. I'll show you as I'm going through here. All right, so we're going to create a string, and then we want to write a loop that goes through the string and outputs the string in reverse. All right, so this is going to be our kind of our practice for loop, dealy flippy guy. Where's my... Here. Make sure this is running. Okay, so let's got that. All right, so I'm going to create a string. We're going to call this guy here. We'll call it task 1. All right, and I'm going to start this guy off as just hello. All right, we'll update it to prompt here in a few minutes. So we're supposed to write a loop that goes through and basically walks the string in reverse, displaying the contents of the string in reverse to the screen. So what's our for loop? For int I is equal to, since we're going to go in reverse. Now, some of you maybe went from 0 to the end and then kind of did the math to make it work. But why not just go to the last legal position in the string and decrement each time through? So the last legal position in my string is its length minus 1, right? So this is task 1.length minus 1. That's the starting point for I. We're going to keep going as long as I is greater than or equal to, what's the first legal position in our string? Good, bucket 0, yep. All right, and each time through, we're going to decrement I. I promise you very shortly, we'll do the I minus minus and I plus plus stuff. I'm purposely avoiding that for right now because it actually will take 10 minutes to explain the nuance of it. All right. Now, one misunderstanding a lot of students had based on questions I got, understand that this for loop, as we have it written right now, really has very little to do with a string. All this loop is doing is taking I, an integer, on a voyage between some number and some other number, decrementing by 1 each time. We get to choose as the programmer how we want to use that number. The way we're going to use that number is we're going to use it to index a particular bucket of our string. All right. So what do we want to do? We want to output our string at bucket I. So it'll be the last character of our string the first time through, the second to last character, third to last character, so on and so forth. So we'll output that guy. Now, you can kick it down a line here if you want, but I'll go ahead and have it display the whole string in reverse on one line, and then I'll kick it down. So we'll output like that, and then afterwards, I'll just do an endl. That'll kick it down a line. So if I run this, it should give me hello in reverse. And there's hello in reverse.
How does the task.length take us to the O?
Task.length, so the length of task right here is 5. The O is 5 minus 1, which is 4, which is why we said task.length minus 1. So the very first time I is equal to this index in our string. So when I say task 1 at bucket I here, I'm grabbing the O the very first time, which is in this case, bucket 4. All right, so
if we didn't put that -1 there, then it would print forward.
If I didn't do the -1 here, it would be trying to get some mysterious character out here off the end of the string. It wouldn't start at the end of the string. It would start one character past the end of the string. And we saw in class last time that in older languages like C and C++, it'll let you get away with it. It won't give you the output you expected, We'll see if we get either a weird symbol or just an extra space, I think we saw last time. So there's actually, notice when I highlight it, there's an extra space right here. So that space is whatever it found in that memory location that was not owned by that variable task1. So realistically, this is bad logic. In a more modern language like Java and C#, it would scream at us. It would give us an array index out of bounds exception or a buffer overload exception, something like that. So as I have it written right now, starting I off at task1.length, in this particular case, says I starts off at bucket 5. And bucket 5 does not exist in this string. The last legal bucket is bucket 4. That's why we need that -1 on there. All right, so there's our -1. All right, so that's task 1. So now what you might do to test this with an input thing is I'll just go ahead and define my string task1. I'll do like a cout, enter a string, and then cin task1, and then the rest of the code should work the way it worked before. I'll go ahead and run this. I'll put in, well, I'll put in world this time. Press enter, there's world in reverse. All right, makes some sense? All right, so now if you're doing your homework all in a single file like this, again, if you're prompting for each one of these, it would get really annoying, right? Because you have to enter your previous 2 tasks in order to even test your last one. So you could go back to have it just hard coded, or another option would be is utilize our multi-line comment and just say, okay, I'm done with task 1. I'll just go ahead and comment that guy out. So I started off with a /*. I end it with an */. And so that means everything in between here is a comment. C++ will ignore it. All right, so we can still see it. The code is there. Takes me 2 seconds to uncomment, but it's no longer going to be a time waster for us as we move on to task 2. If I run this guy right now, all programs begin and end with main. What does main say to do? Nothing. So I'll run this, program will run and show me no output. All right, so let's move on to task 2. Where's that guy? Let me hide this. Task 2, write a program that asks the user to enter a sentence. Okay, so this is the first place where this gets a little sketch. All right, we're going to write it generically like I just did. We're going to create a variable. We're going to hard code a sentence in there, and then we'll write the logic. But then when we go to read it in, to prompt, when we actually prompt the user and read it in, we're going to see if we use our traditional way of reading it in, it only gets us the very first word in the sentence. And there's a reason behind that that I'll talk about when we get to it. But let's focus on the logic first. We'll hard code a variable. All right, so we're going to put a sentence in here. So I'll start down here. Here, let me just put some spaces in here so I can. So I'll say string. We'll call this guy task 2. So I don't know, let's just do something like that. All right, we wrote a sentence. All right, now what does task 2 tell us to do? It tells us to write a program that asks the user to enter a sentence and then counts and displays the number of vowels that are in that sentence. So it just showed lowercase vowels. If you did it for uppercase vowels too, that's fine. Doesn't really matter. Really, what's the logic here? We're focusing on loops. We're focusing on asking the question, is a certain character a vowel? Okay. So we're going through the string forward. So we'll write our stock for loop for int I is equal to 0. I is less than task2.length. I is equal to I plus 1. All right. So now again, this loop has nothing to do with the string. It just takes I on a voyage between one number and another number, and we as programmers get to choose how we want to use that number. We're going to use it to index buckets of our string. All right. So we want to ask a question. We're going to keep track of a count. So we need to remember something. So we're going to create a variable. Say int, let's call this guy val count. We'll start off at 0. All right, so we're naming our variable something reasonable for what it's supposed to be. C++ doesn't care. You can name your variable just banging on the keys or something like that if you want, as long as there's not spaces. But you probably want to name your variable something meaningful to you. All right, so at this point, we have found 0 vals, so val count is 0. Inside the loop, we want to work with the current character in our string, which is task2 at bucket I. So everybody agrees that that right there will boil down to a char, which is the current character that we're looking at in our string, the character at position I, right? All right, so now we want to ask some questions about that character. We want to know if it's a val. Okay. So what I'm going to do here, I'm going to go ahead and store that character inside of a variable. We don't actually have to do this, but you're going to see our if statement's going to get a little bit big. So maybe having a quick little throwaway character is going to be beneficial for us to, instead of having to say task2 at bucket I over and over and over again, we could just say like C. All right, so we'll remember this character inside of a variable right here. Now we want to ask a question. If the problem we're trying to solve right here is we want to know if the character stored inside of this variable named C, in fact, well, let's leave it C, is that a val? The way we ask that is we compare it to all the vals. So if C is equivalent to an A, or C is equivalent to an E, or C is equivalent to an I, or C is equivalent to an O, or C is equivalent to a U. Remember, when we use ors, only one of those need to be true. So if C is equal to any one of those chars, and you do have to write it this way, you can't just say C equals A, comma, E, comma, I, comma, O, comma, U. So typically, if you're asking yourself, can I write this in a more compressed way? Go ahead and assume the answer is probably no for right now. Eventually, you might learn there's some tricks, there's some more compressed ways you could write things, but don't try to take shortcuts, especially when you're a beginning programmer. You're just going to run into more problems. Spell it out. All right. So if it's true that C is either an A or an E or an I or an O or a U, if any of those are true, I'll put a little comment in here. C must be a val. And what do we do when we have a val? We increment our val count. Val count is equal to val count plus 1. Go ahead. You can. I mean, it's going to be just more ors in there. I think in the actual assignment, I just showed the lowercase ones, but doesn't matter. So you could say or capital A, or C is equal to capital E, or C is equal to capital I, so on and so forth. We're going to learn a better way of doing this later on that won't require a zillion if statements. And it's actually something we kind of already know how to do, but you probably didn't write it that way. All right, so if the current character we're looking at is a val, we'll increment val count. If it's not a val, we're not going to change our val count. We'll just move on to the next char, right? So this loop takes I on a voyage between 0 and the length of our string -1. Each time through, we're going to use that integer to find out what the current character is at that position. We're going to ask the question, is that character a val? If it is, we'll increment our count. If it's not, we won't increment our count. When this loop is done, so when we're completely done with the for loop, val count should now hold the number of vals we ran into, right? So C out. let's just say val count. I'll write some sentence out. So right now for what do we have? We have 1, 2, 3, 4, 5, 6 vowels on this guy. So we expect to see an answer of 6. There's our 6 right there. All right, so before I go and address the whole reading in a sentence thing, are there questions about this? Now, I want you to maybe focus on when I'm writing code. Notice I'm saying a lot of stuff out loud, right? I am saying the stuff that you should be thinking about as you go through there. And notice that I take little tiny baby steps, right? I say, what are we trying to do first? And we write the code to do that. Okay. I keep mentioning that this loop's only taking I on a voyage. We need to now use I in some sort of intelligent way. We're going to get the character we are currently interested in our string. Okay, I have that. What do I do with that character? What am I interested in? I'm interested in finding out if it's a vowel. Before you just dive into the code and start writing a solution to something you don't even know what you're writing yet, make sure you ask yourself, what is the next little problem that I'm trying to solve? And write the code to solve that problem. All right. So let's go ahead. Here, I'm going to copy this sentence so we can bump into our problem. All right. So now I'm going to go ahead and read in. I'm going to prompt the user for a sentence, see out, enter a sentence. And then I'll say CN task 2. Now, right away, let me just go ahead and echo back out what we just read in. All right, so I'm going to prompt them. I'm going to read in something. I ended my statement right there. I just defined a variable called task2, and then I commented the rest of this out. We actually didn't have to do that since we were overwriting it right here anyways, but this is probably the more correct way of writing it. So I have myself an empty string variable. I prompt the user. I read what the user typed in into that string variable, and then I'm just going to output the string variable proving to us that we got the thing we expected to get. All right, so I'm going to go ahead and run this. I'll paste in that sentence, and then when it echoes back out, it only got LOL. Not what we actually wanted. We wanted the entire string. Now, I mentioned on Slack, so if you're not checking Slack regularly, make sure you look at it because I gave you the solution to this problem. What we would actually do is we're going to use a function called getline that uses the input stream CN and reads the answer into task 2. So if I run this and I paste this in, now we get the whole sentence. But even that has a kicker. So now what I'm going to do is I'm going to uncomment the code up here where I'm still reading in from the user using CN. So it's asking for a string. This is the first string. I'll type in hello. Now notice it never gave me the opportunity to enter something in there for enter a sentence. There's a reason for it, and it's stupid. Remember, this is very old. These are very old libraries. All right. When I typed in hello here, at the very end of that, I pressed enter, right? To trigger it to read it in. Well, all it read in was the HELLO. So what was still sitting on that CN input stream was a carriage return, a \n. So as soon as we did getline from CN task 2, notice it did prompt me. It said enter a sentence, but it never paused waiting for me to write something in because it found something already sitting there. it found that carriage return just waiting inside that inside of CN to get the and it read that in as if that's the sentence you put in there. All right, so that's why we got 0 vowels, because we read in an empty string. We read in a string that just has a carriage return in it. Make some sense? All right, so what's a solution? Well, we could replace this line here with getline CN task 1. So instead of using CN directly, we just use getline every single time. And now we'll see that we can say hello, and then we can type in our sentence. Works both ways, because getline reads in the entire line, including the carriage return. Because you might put carriage returns in there and then also write some more stuff potentially if you're reading from a file or something like that. When you're typing it by hand, you don't really have that option of kicking it down the line. But in any case, that's kind of the deal with that. A little frustrating. I wouldn't focus too much on reading stuff in from the user right now. I've kind of just shown you that that ability. Most of our modern applications, you're going to be, users will be typing something into a text box or something like that, or whatever. You're not going to be prompting them at a command line. So this is more just giving you that little skill. In general, like we're doing in here, hard code your strings so you can test. You can throw the read it in from the user thing at the end if you want to have it be interactive. But I can understand that was probably a little frustrating. But there's some rationale behind it, so hopefully that makes some sense. All right. So this is that task 2 where we're counting vowels. So it makes sense how this is asking whether the current character we're looking at is a vowel. All right, we'll come back to this here in a few minutes and look for maybe a better way of detecting vowels when we introduce some functions. All right. So let's go ahead and comment out this guy, move on to task 3. Still in here. What's task 3? Convert a string to uppercase. Okay, so this one is a fun one. Remember all that time I spent talking about ASCII and Unicode and how chars are actually stored as integers? That probably went in one ear and out the other. That would have been helpful in this one for you. So again, we're going to iterate through a string. So let's start off with our defining a string. So we'll say string task 3, and let's go back with our hello, short and sweet. Then we're going to write our stock loop that we use to spin through every character in a string. Where int I is equal to 0. I is less than task 3 dot length. I is equal to I plus 1. Again, all this loop does is take I on a voyage between 0 and the length of the string minus 1. Numbers. We get to use those numbers in however way we choose. We're going to use them to access the current character in our string. All right, so task 3 at bucket I is a char. And it is that char that we want to convert to uppercase. All right. So now the question we want to ask ourselves is, how do we convert it to uppercase? Well, first of all, we want to make sure it's a lowercase letter first, right? So how do we ask if a character is lowercase or not? So we'll put a little comment in here. Is this a lowercase char? We're asking a question, so we use our if statements, right? So if that char, so task 3 at bucket I, is a char. If we want to stay consistent to what we did above, maybe we go ahead and say, we go ahead and throw that in a variable. just because we're going to be potentially using that value multiple times and saying task 3 at bucket I over and over and over again might get a little tedious. Now we can just say C whenever we want to use it. All right, but understand this is quality of life stuff. We already have that value stored inside of bucket I of task 3. We didn't have to store it again. All right, so we want to ask a question. Is the character stored in C, is that guy a lowercase character? Because we only want to do something here if it's lowercase. If it's lowercase, we want to turn it into uppercase. However, we're going to accomplish that. All right, but we only want to do that if it's a lowercase letter. So how are we going to ask if it's a lowercase letter? Well, it's a lowercase letter if it's somewhere between and including a lowercase a and a lowercase z. So if C is greater than or equal to A and C is less than or equal to Z, then it must be a lowercase letter. Remember, these are numbers. This is just math. Under the hood, let's go and bring this up. So we'll do an ASCII character chart. So here's our ASCII table. If I go and I find my letter A, here's A right here, we say that A is actually equal to the decimal value 97. B is 98. C is 99. All right. And just to show you a quick little example here to kind of prove this point, I'm just going to cut this real quick. All right. I'm going to say char C is equal to a lowercase a. And I'll output C. If I run this program right now, we expect to see a lowercase a displayed on the screen, right? Go ahead and run that. There's our lowercase a. But now if I say C is actually equal to C plus 1, doing math with a character, but we know that characters are actually stored as numbers. Doing math with it is just fine. Now I'll show you a little trick here to prove to ourselves something. So I'll say C out, show me the integer version of C, just so we can see what's under the hood. There's our 97. That's where that guy maps to right here, that 97. This is a lookup on the ASCII table, or in more modern languages, the Unicode table, where A is also a 97. Because Unicode is a superset of ASCII. The first 256 characters in Unicode are the ASCII character set. All right, so this shows us that under the hood, C, which is a char, is actually a number. But because we're working with a strongly typed language, whenever we went to print out the value of C, it didn't give us the number. Instead, it said, this guy's of type char. I'll go ahead and do that lookup for you. That's why it showed us the lowercase a. Where in this line, this is called typecasting. I forced it. I said, look, don't treat this as a char. Treat it as an int. Just trust me on this one. All right. So that's where we got the number on the second thing. We didn't change the value of C at all. If I go and print out C again in the very next line, we're right back to our A. All right. So this just changed. This showed us what's happening under the hood with that chart. All right. So we can do math with integers. We can add numbers to them because they're stored, or math with chars because we can add numbers to them because they're stored as numbers. So let's go back to our code. All right, so we have a character. We're going to ask, are you a lowercase character? If you are, we want to now ask the question, how do we convert you to a uppercase character? Well, let's go and look at this. So we see that a lowercase a is a 97. And uppercase a is a 65. 97 minus 65 is 32. That means they are 32 apart from each other. So if I took a lowercase a and I subtracted 32 from it, what would I end up with? Uppercase a. All right. So if it's a lowercase value, I can go ahead and say C is equal to whatever C currently is minus 32. But we're only going to do that if we're looking at lowercase characters. Otherwise, we subtract 32 from like a question mark, we're going to get stuff. We'll get real stuff, but it's probably not going to be, it won't be an uppercase question mark. That doesn't make sense, right? So we only want to do this crap if we're dealing with lowercase chars. If we're converting to lowercase, we'll ask, is this uppercase? And then what will we do? We will add 32 to it to go from uppercase to lowercase. Good news for us is most modern languages have a character class in it that has a function called toUppercase or toLowercase that just does this math for you behind the scenes. But because we're budding computer scientists, we like to understand what's happening under the hood so we can appreciate what those power tools are doing for us. Make some sense? All right, so we'll get the character in the string we're interested in. We'll ask the question, are you a lowercase character? If you are, I'll overwrite the character I currently have stored with the uppercase version of itself. All right, regardless, when I get to this line, I want to go ahead and, are we supposed to store it or just output it? Convert each lowercase. Okay, so we'll go ahead and just output it here. So any way you cut it, when I say C out the value C here, it is going to give me either the character we originally read in or the modified character if it happened to be a lowercase character. Make sense? And then after the loop, I'll do an end L to kick it down a line. So task 3 is currently hello. We expect it to give us an uppercase version of hello. There's our uppercase version of hello. Now, if we put some question marks and spaces in there and maybe a couple of commas, we expect this to be an uppercase hello followed by the exact stuff we already have there. So there's our hello, but still the question mark, the space, the comma. It ignored those because those were not lowercase characters. All right, makes some sense? All right, so this one probably was a struggle for a lot of folks because this kind of was your first step towards trying to put together some of these things about that we've been talking about in class in terms of how do things actually work under the hood. And now you're putting that together with your beginner programming skill set and your beginner problem solving skill set for converting the problem you're trying to solve into something a computer is going to understand. Okay, so a lot of moving parts going on there. All right, so this was meant to probably be a struggle. All right, the sentence reading in part was not intentional. That was not an intentional thing for reading it in. I didn't foresee that. But this one's a kind of a fun one. It's something that gets done for us in modern languages, but it's still the same thing happening under the hood. So this reinforces for us the idea that computers like numbers. It's storing chars as numbers under the hood. All right. Comment out that guy. All right. And then validate password. All right. So this is really actually this one wouldn't have had the problem with the getline one. All right. So we're going to go ahead and do basically the same thing we've done before. We'll go ahead and hard code in a password for testing it. And if you want to then prompt the user for it, you can. So we'll create a string called task 4. And we're going to set this guy equal to a password for us. There we go. Perfect password. Go ahead.
Going through this, I've done getting a problem with uppercase when the first letter. So I don't know.
What do you mean when the first letter changed?
So if I entered a password with a uppercase, it would tell me to, well, if I entered a password with uppercase, lowercase, lowercase, it would say enter a lowercase. if I did a lowercase, uppercase, okay, so it's probably
Okay, let's let this keep cooking and see if your solution to your problem pops up. If it doesn't, ask again, because I mean, realistically, it's you had some logic error in it, right? So without seeing it, I can't tell you, but let's let this play out and see where it goes. All right, so we're looking at this password. We want to know, is this a legal password? How do we find out if something's a legal password? Well, we have to go through every character of the password, right? And see if it meets all our rules. So our password's stored in a string. We want to go through every character in a string. Do we happen to have a tool for doing that? Same old for loop, right? For int I is equal to 0. I is less than task4 dot length. I is equal to I plus 1. Again, this takes I on a voyage between 0 and some number. We're going to use that number to index in our string. So now let's look at what our requirements are. So a password has to be at least 8 characters long. So we can actually check that ahead of time, right? We don't even have to loop through it if it's not at least 8 characters long. So before this for loop, let's ask the question. If task4 dot length is less than or equal to 8, let's see, it can be at least 8 characters long, so we can take the equal off. If it's less than 8 characters, for right now, let's just output it's a bad password. All right, we'll figure out what we actually want to do with that knowledge in a few minutes, but we're flagging the bad parts of this thing right now. So we'll do a cout. We'll just do password too short. All right. Now, realistically, we don't even want to get to this loop if this guy was off, right? But if this guy is still, if we pass this test, if task4's length is greater than or equal to 8, that means so far the password's okay. So now we need to go and check to see if it has the right number of the other stuff. So we'll throw an else in here. So we're only going to do this in the event that this was false. And this would be false if our password length is at least 8 characters. So if we already have a password that's at least 8 characters long, we're still good. So now let's go ahead and check for the next requirement. So let's look at our code or our assignment. Password must be at least 8 characters. The password must contain at least 1 uppercase letter and 1 lowercase letter. So we need to go through every character in our password, assuming it was long enough. And we want to check, was there at least 1 uppercase letter and at least 1 lowercase letter? So maybe we go ahead and count the number of uppercase letters and count the number of lowercase letters. Maybe storing those guys in variables, maybe called count upper and count lower. So let's create a couple of places to remember stuff. So before this for loop, we'll say int count lower. Start that off at 0. Int count upper. Start that off at 0. Remember, these variables can be named whatever you want, but probably name it something reasonable based on what you're trying to store in there, right? We're counting upper and lowercase characters. So now as we go through our string, we'll go ahead and stay consistent. We'll go ahead and put task4 at bucket I. We'll store that in a char variable for us to conveniently work with. Again, you don't have to put it in a variable. We already have access to it through task4 at bucket I. Okay. So now we want to ask some questions about C. We want to say, are you a lowercase character? If you are, we're going to increment our number of the count for lowercase characters. How do we ask, are you a lowercase character? Well, if C is greater than or equal to a lowercase a. That was lowercase, right? Password must contain at least one uppercase letter and one lowercase letter. Okay. So if it's greater than or equal to lowercase a and C is less than or equal to a lowercase z, must be a lowercase letter. It's just a comment in there. So if it's a lowercase letter, if we're inside this if statement, we're going to say count lower is equal to count lower plus 1. All right. Now, if it was a lowercase character, we don't even have to check to see if it's an uppercase character, right? All right. But if it wasn't a lowercase character, it still might be an uppercase character. So we'll go ahead and do an else if C is greater than or equal to a capital A and C is less than or equal to a capital Z. If both of those things are true, then it must be an uppercase letter. All right, so what do? We say count upper is equal to count upper plus 1. Okay. Now, if it's neither of those, is there anything else we need to do? Or do we just move on to the next character? Because we presumably have a password that's at least 8 characters long. We're just counting how many lowercase we find along the way, how many uppercase we find along the way. We really have no other requirements. So we don't need an else to this. We're asking 2 questions. Are you uppercase? Are you lowercase? And counting along the way. Now let me ask you this question. Did I need the else if, or could I just had 2 ifs there? Let's ask it this way. Would that have worked, writing it this way? Yeah. But am I potentially being redundant? If I happen to find out that I was a lowercase character, is there any possible way for this guy to be true? If it was a lowercase character, it is impossible for it to be an uppercase character at the same time, right? So wouldn't you agree that I'm wasting my time asking that question? That's why we put it in an else if. Now we know it's not going to break anything. You know, yeah, you're wasting your time, but hey, if you want to get the microscope out and find out if that lowercase character is also an uppercase character, you're going to fail every time, but have at it. It's not going to break our count. We're just asking some questions we don't have to ask. All right. So we'll put that else if back in. All right, so only check for uppercase if it wasn't lowercase. If we get past both of those checks, we have no other checks to do. We just want to move to the next character and check that guy, right? Now, we potentially could do some stuff here where as soon as we hit one lowercase and one uppercase, we can say, we're good. But unfortunately, we, at this point, don't have the tools to get out of the loop early. We'll look at that here in a minute as we just kind of expand on this some. But for right now, let's just say, look, we're going to count how many lowercase characters we found. We're going to count how many uppercase characters we found. At the end, we'll look and make sure they're both at least 1. And then we'll give the thumbs up or the thumbs down. Okay? So we just move up to our loop and move on to the next character. Now, by the time I'm here, we want to find out, is there at least 1 uppercase and 1 lowercase character? Well, how do we ask that question? If count lower is greater or equal to 1, actually, let's go for the error side of this. If count lower is less than 1, or count upper is less than 1. If either of those is true, this is a bad password, right? Now, we could ask it individually so we can give them a more targeted error message. We could say, look, if you have less than one lowercase letter, you don't have enough lowercase letters. If you have less than one uppercase letter, you don't have enough uppercase letters. But let's just do a catch-all here. So we'll say cout. We'll just go bad password. Something like that. All right. So at this point, we're throwing some commentary in here. We have our proposed password up here that we know has plenty of lowercase characters, but has no uppercase characters. So this should be a bad password, right? It's long enough. So we'll get past this guy right here. We'll get past that. But then when we get into this else and we go and count the number of lowercase and uppercase, we're going to find we do have more than one, or at least one lowercase, but we have 0 uppercase. So we should, when we get down to this if statement, we will succeed here. And actually, this shouldn't be an or, this should be an and. Because both of these need to be true, right? Actually, no, because I'm doing the error on this. So if you have too few lowercase characters or you have too few uppercase characters, we're going to say it's a bad password. So in this case, we're going to have a bad password, but because there was too many or not enough uppercase characters. So let's just go ahead and run this now. We're not actually asking it extra time yet. You know, we're not reprompting them for it, but we're testing our logic for good password, bad password. So this is a bad password. So if we go ahead and just throw one uppercase character in there, let's just make that W a capital. Now it's at least 8 characters. There's at least one lowercase. There's at least one uppercase. The output of my program here is going to be nothing. I didn't put out anything about it being a good password. I just yelled at you when it was a bad one, right? So if I run this right now, we're not going to get any errors. We get nothing. All right. So we are, let's just say we're properly checking for good and bad passwords now. All right. So now we want to ask them for their password again if they put in a bad password. But we want to ask them for their password at least once, right? So because we want to ask them for their password at least once, we probably want to look for a loop that executes at least one time. Do we have one of those? Do while loop, right? So we want to do all of this junk. Indent that there. So we're going to, oh, sorry. All right. So we're going to do all of this stuff. And I'll go to put a little, well, we want to keep doing that while what is true. We want to keep asking them for a new password as long as they keep giving me bad passwords, right? So we have to have a way of keeping track of, a way of remembering, did you give me a good password or a bad password? So maybe we create a Boolean, or you can create an integer or whatever, but Booleans would probably make the most sense here. So at the beginning, we'll create a Boolean. We'll call this guy is good password. And as far as we know at the beginning, we have a good password. We're looking for reasons to flip that to false, right? Now, what I'm going to do here, I'll go ahead and define is good password before the loop starts. And every single time we start this loop, we're going to start back off with the assumption that it's a good password. Is good password is equal to true. Similarly, we're going to define our string before this loop starts. And we'll probably prompt the user in here, but right now I'll still hard code it. So I'll say task4 is equal to that string. So what are we going to do? Read in the password. Initially assume it's a good password. Then go through and try to prove that wrong. Prove that assumption wrong. So if the password was too short, what can we say? Is good password is equal to false. Right? Else, we do all this checking and stuff. If we didn't have enough upper or lowercase characters, is good password is equal to false. Now, there's no place inside of my logic here where I flip it back to true. It starts off as true, and then I go through this minefield where we might flip it to false. Now we can ask the question. We want to keep asking you for passwords while is good password is equal to false, or while not is good password. So as long as you have not given me a good password yet, we're going to do this whole exercise again, and you're going to give me a new password. We're going to assume it's good this time around again. Then we're going to check it for badness. All right. Over and over and over again. And then afterwards, we can do something like cout good password. Something like that. All right. So right now we know we have well, let's throw in my bad password, right? So that's our bad password with a lowercase w. So we don't have any uppercase characters here. So let's run this. What's going to happen when I run this code? It's going to loop forever. I'm never changing my bad password. I'm pretty set on this on this password, but at the very least, we'll see that it's going to keep looping, right? And we should get bad password, bad password, bad password. So this will at least give us experimentally evidence that we're going through this loop over and over again because we're not clearing the we're not clearing the bar down here when we check. Hey, was it a good password? We're going to keep going as long as it wasn't. But as soon as it was a good password, then we'll fall out of this loop and we'll output good password. As it sits right now, this is a bad password. Make sense? All right, so stop that there. Now, just for the sake of argument real quick, let's just put in a too short password in here. It also doesn't have enough uppercase characters. So we're actually going to get two bad comments each time through. It's too short and it's just a bad password. And we'll get that in perpetuity. Bad password should be in there. Oh, we're never getting into that with the else. Still a bad password. All right. So let's go back to, we'll change this W to a good password. Make sure it clears the hurdle this time, right? We know it's long enough. We know there's enough lowercase characters. We know there's enough uppercase characters. We're going to go through it at least once because we need them to enter their password one time. But at no point in here will we be setting is good password to false because it is long enough and it had enough of both of these guys. So when we get down to this and we're saying, well, not is good password is currently equal to true. So it is a false statement to say that good password is equal to false. So we will fail on this loop, fall past it, and we have our good password. So understand kind of a problem-solving approach here. Our logic here is not looking for good passwords. Our logic here is to prove a bad password. And we only let them through once we cannot prove it's a bad password. So we're almost kind of like solving it backwards. So now we'll run it. We'll see we have a good password. And it doesn't loop again because we got out of that loop. Okay. So now we can go ahead and update this for prompting. So we'll say cout, enter a password. CN task 4. Rinse, lather, repeat. So, and now since one thing I'll throw in here is this line right here, it's what's called a blocking line. My program will pause when it gets to that line because it's waiting for input from us. So I'll run. We're going to go ahead and enter a password. Let's give it a bad one. It says password's too short. Enter a password again. Let's do LOL, woot, couple exclamation points. Still a bad password, right? This guy's long enough, but no uppercase characters. That's a bad password. So LOL, capital W, OO, something like that. Finally, we have a good password. There's my good password. But it kept asking me until I finally gave it something it was happy with. Good.
So if you do like, let's say for your first one, all lowercase. And then if you do for your second one, all uppercase.
It'll fail because this if statement down here is checking both of those. So we'll go ahead and run it and we'll see that it fails. So we'll do LOL, like we went all uppercase, LOL, woot, something like that. It's going to fail again because it didn't have enough lowercase. Do all lowercase, so we'll do LOL, woot, still a bad password. Got to have at least one of each of those. Now, we could have been a little bit clearer here. We could have had an if statement that said, is count lower less than 1? If it is, you don't have enough lowercase passwords, then have lowercase characters, then have a second if statement that asks about uppercase. So we can tell you kind of where you went wrong. So we could be a little bit more specific about, what are you actually missing so you can write a better password the next time through. All right. So questions about that one?
Yeah, is there a link to Slack on the Blackboard page, or do you have to download an app or something?
Yeah, well, I mean, there is a link. It's in the first announcement. If you look at the first announcement for the class, I had 2 things that were high priority. One was do the first assignment so the university doesn't kick you out of the class, and the second one was join Slack. So if
Right?
you go and look at announcements, it's in there.
Okay.
All right. So let's look at some better ways of doing a couple of these things. For starters, just so for my own sanity, why don't we cover the plus, plus, minus, minus stuff real quick? All right. So for those of you who are programmers or have done programming before, or when you've looked at code online and you see them saying things like I plus plus or plus plus I, and you see I don't write that, it's because I haven't taught you that yet. Let's go ahead and talk about that because it's not as straightforward as you assume it is. Plus plus and minus minus operators. It's very handy that it didn't give me. Nailed it. All right. So now let's say I have an int a is equal to 5. I can say a is equal to a plus 1. And now a will be 6. I can say a plus plus. Now a will be 7. I can say plus plus a. Now a will be 8. I can say minus minus a. Now a will be 7. I can say a minus minus. Now a will be 6. All of those ultimately result in the same logic, but they do behave a little differently. All right, I'm going to kind of take you through that here in a second. So for starters, let me go ahead and put the link up from my saved code here. Right now, keep in mind, I have task 1, task 2, and task 3 still commented out. So I guess I can uncomment those. Okay, so I'll save this. I'll share this. Put this on Slack. So there's your link for homework 4. For you to check out. All right. So now, let me go ahead and just gut this. All right. So let's create a int a. We'll start that off at 5. Now we'll go through that same exercise. So if I do cout a, we're going to get a 5, right? Then we're going to say a is equal to a plus 1. Now we're going to get a 6. Now we're going to say a plus plus. Now we're going to get a 7. Then we're going to say plus plus a. Now we're going to get an 8. Then we'll say minus minus a. Now we'll get a 7. Then we'll say a minus minus. Now we'll get a 6. All right, so there's our outputs there. Nothing seems overly dramatic there. Seems like plus plus adds 1, minus minus subtracts 1, but both of them do ultimately change the value of the variable. So we can say that from a logic perspective, a plus plus and plus plus a both ultimately result in the same thing as saying a is equal to a plus 1. Similarly, a minus minus or minus minus a, whether you put the minus minus beforehand or the minus minus afterwards, ultimately result in the same thing as a is equal to a minus 1. Anybody know the difference between putting the minus minus beforehand and the minus minus afterwards, or the plus plus beforehand and the plus plus afterwards? Okay, this is why I don't introduce this until a little bit later, because if you learn this and you just look at it and say, oh, the way I increment is just saying plus plus a, or the way I increment is saying a plus plus, you never actually find out the idiosyncrasies of this. Let me show you what I mean by that. So we all agree that if I define a variable name a and set it equal to 5, and then I print it out, we're going to get a 5. Everybody's cool with that? That shouldn't be shocking. All right. So now what happens if I say cout a plus plus? The situation that we're going to run into here is, how does it change when we use it directly as part of another statement? Now, I'm going to encourage you never to do this after we explain what happens. But sometimes you're going to do it, or sometimes you're going to see somebody else's code where they've done this to try to seem fancy, and you want to be able to read the output. So if a equals 5, and we output a, we get a 5. And then I output a plus plus, what's it going to output? Only if you haven't ran it already. How many of you assumed 6? A plus plus adds 1, right? We're still going to get a 5. But notice that if I just print out a on the very next line, a indeed is now 6. It did change. But having the plus plus after the a means when I'm printing it out, it says resolve the current value of a, which is why it outputted a 5, and then add 1 to it after. Since the plus plus is after, we are changing the value, but we're changing it to 1 more after we get the current value. Make some sense? So that gave us 5, 5, 6. But if I do this, cout plus plus a, I put the plus plus before, what this will do is it will change the value before. give us the new value, which will be a 6. So now this will be 566. Make sense? Minus minus works the same way. Go ahead.
Like the bitwise and not.
No, no, this just has to do with order of operation. When I say, let's just kind of spell it out here. C out plus plus A is the same thing as saying A is equal to A plus 1 and then C out A. These two lines are equivalent to that one line. We want it to change first, then display it. As opposed to A plus plus is equivalent to that. Display it first, then change it. All right, makes some sense? Now let me ask you this. Is there logically any difference between those three lines? As I have them written right now? Every single one of them will do the identical thing because I am not using the value directly. I'm doing this math, then I'm going to do whatever I want with the value. So this is more similar to like the curly brace argument. It's never wrong to put this stuff on one line, to do it by itself, and then use it on the next line. Use the changed value later on. All right. When you start getting fancy like this and embedding it inside of your code, that's when you start running into problems. That's when you need to rely on you understanding how that plus plus works when it's before versus after. All right. These are, I mean, I know it seems nitpicky, but these are so important in computer programming because it's the details that are important. Because if you're looking at somebody else's code and you don't understand that nuance, you might spend hours searching for an answer because you're getting a result that's one off what you expected. It's because it actually changed the value at a different time than you thought, because you thought all pluses were created equal. Make some sense? So there's a lot of detail here. It is important stuff, but it's stuff that we almost have to stumble onto. Okay. Good for you. I didn't have time to get to our next assignment, so I guess you get a little breather. Maybe for Thursday, since I know some of you struggled either with doing the previous assignment or had a online GDB issue, maybe go through it, just make sure you wrapped your mind around it, and we'll come back and we'll do, I'll show you a little bit better way of doing the looking for vowels using strings, and then we'll get into function. All right, I will see everybody on Thursday.
I did after you told us to do it like said it just built fill out something on Blackboard and tell you what happened.
It's fine.
I it did submit that to you.
Yep.
It just is a few.